Hey everybody, welcome to Bulb. I'm not going to use a mic because I need my hands free. I could do with one of those kind of Eurovision style boom mics, but I don't have one today, so you'll have to pick up. Assume everyone can hear me. Yeah, it's not too bad. All right, cool. So yeah, welcome to Bulb. We're really proud to be hosting the first DevOps Roundabout. We host quite a lot of meetups. This is the first kind of one that's DevOps related or infrastructure engineering related. I thought I'd start by just talking a little bit about my role at Bulb, what I'm up to, talking about our stack and kind of what we're building, and then that'll kind of naturally segue into kind of like the talk, which is kind of like around Terraform and continuous delivery of cloud infrastructure. So I joined Bulb last year to found the platform team. If you imagine kind of like what an energy supplier might be up to internally, we have to kind of run services which do stuff like provide account management to our members, collect meter readings, compute consumption, compute billing amounts, and then go and communicate about it. When Bulb was founded back in 2015, obviously we didn't have the funding at that time to kind of fund a greenfield technology project to go build all that stuff, so we bought some vendor software off the shelf, and that's what's been kind of running Bulb, like the core of Bulb, for the last 4 years or so for the UK market. The idea of the platform team is to take that software out and replace it with our own internal Bulb platform, which will be a microservices architecture, and it has a microservice for each of those kind of domain entities that we just talked about. So one for an account, one for billing, one for meter reads, one for a meter identity, and so on. The stack that we're using for that is their services are written in Python, they're Flask apps, they're Dockerized, deployed to Kubernetes. We're using GCP as our cloud provider. To deploy into GCP, we're using Circleci for continuous delivery. We're using a trunk-based development model. So our developers raise a PR for each feature that they might deliver, merge into master, and then that gets deployed into production or via some testing environments first. So we have a bunch of tiered GCP projects. We have replicas of our infrastructure across dev, staging, and production. We merge into master, and then from there it's fully automated. So we'll deploy into dev. Ahead of deploying into dev, we'll run static analysis, unit tests. Then we'll run integration tests, smoke tests post-deployment, deploy into staging, run the same sort of cycle again, a different set of tests, maybe slightly richer end-to-end tests and another set of smoke tests, and then it will go to prod, and that's it. So there's kind of only one click for the deployment. I think that's most of the stuff I want to talk about. On the other side, we kind of got the infrastructure as well. So the platform devs, on one side, we have a monorepo for all of our application code written in Python. The other side, we also have an infrastructure monorepo. All of our infrastructure is provisioned using Terraform, which is a cloud orchestration tool. Who's using Terraform at the moment? A few people. Who's like, yes, the platform team put their hands up. Cheers, guys. Who's kind of familiar with what it is and how you might use it? Okay, most people, we can do it. Okay, I hadn't planned to give a Terraform talk. Well, partly. So we're using Terraform anyway to provision all of our resources. Those resources that we're provisioning are typically like GCP managed resources. So I would say that we kind of have more of the, when Bartosz was talking earlier, he kind of had capital dev and small ops. We're all developers on the platform team. Again, they're smiling at the back. We don't have too many people more on the ops side. And almost all of the GCP resources that we use are kind of managed services. So for example, all of our Postgres, our relational data stores on our backend to each of our services, our Cloud SQL databases. And that's managed up by GCP. All of our Kubernetes is actually GKE, and that's a managed version of Kubernetes as well. So we kind of just have to manage the configuration like Kubernetes, and the rest is handled for us. Our infrastructure also has a CD pipeline in place. So one of the nice things for the platform devs is they can kind of write some Terraform, test it out in kind of like a toy environment that we have, raise a PR, and then we'll merge that into master, and then that will get deployed across 3 different tiered environments. So we test our infrastructure changes in the same way. So if you wanted to spin up a new Postgres backend, we have a Terraform module for that. The CD pipeline will plan, pause on an approval step to say, hey, are you sure you want to approve this at this point? Are you sure you want to deploy this into this environment? You go check the plan, look at the change set that's going to happen, and then we just go deploy and push that into the environment. And the same change gets propagated up the environment stack from there. Cool. Any questions on that so far? I'm happy to take questions as we go.
You've chosen to use a monorepo approach for for both the sides, yet you didn't combine those together? What was your reasoning for keeping the infrastructure and the code?
It would get absolutely gigantic, and I think the CD pipeline would get really complex as well, managing those two things at the same time. I think one of the other pieces is we know that the platform team as a whole and Bulb as a whole's engineering organization is also going to grow over time. So splitting some of those responsibilities, how we manage our infrastructure and potentially some of our configuration, putting that in one of the repos and then putting all the application code where we're really, really focused on business logic in another place has kind of felt like a sensible split. Yeah, there's a whole thing around how our configuration gets deployed that's quite interesting, but that's probably another talk for a different day. Cool, so that is a fair introduction. So I thought, okay, how can I put together a talk that demonstrates some of these principles? So we could walk through it together today. One of the kind of tools that sprung up in the last few years is something called Netlify. Does anyone use that?
Netlify.
Netlify, yeah. I'm never quite sure how to pronounce it. Basically, it's this pretty cool SaaS. That allows you to deploy static sites really, really quickly. So you write your HTML, you push it to a repo in GitHub, GitHub fires a webhook notification, that triggers Netlify to go fetch or check out your code base and then go deploy it for you. It's extremely quick and really, really cool. I like that a lot. And they're pushing this thing called the Jamstack, which I was like, what the fuck is the Jamstack? They gave I went to this website actually, which is called jamstack.wtf, which is perfect. And then they had this really useful architecture diagram, and I was like, what the fuck is Jamstack? It still doesn't make any sense to me. Apologies for swearing. So they say a little bit further down that it's JavaScript, APIs, and markup. It's still not that clear. I think most of the time it's, hey, deploy a static site somewhere. That static site is cacheable. It's going to load extremely fast from a CDN. And probably your backend is some sort of Cloud Function, AWS Lambda or something like that. That Cloud Function is taking input from your front end, transforming it, and then probably farming that out across a bunch of different backends, like third-party backends like Stripe and so on, whoever your payment provider might be. So I thought, oh, that's really cool. How can I over-engineer this into a convoluted bunch of Terraform modules, which I can show off in a DevOps talk? And that's what we've ended up with here. So maybe actually if I start off by just talking through the architecture that's necessary to deliver this. So, okay, so firstly, our HTTP or HTTPS connections hit a forwarding rule in GCP. That hits a HTTPS target proxy, which terminates the HTTPS connection. That hits in turn a URL map, which knows how to map to our different backend services. Our backend service for a static site is just a GCS bucket, and then a public object within our GCS bucket is also a index.html file. On the other side, we kind of have a HTTP forwarding rule that takes a HTTP connection, forwards it to a HTTP redirect service, which in turn forwards it back to the HTTPS service as well. Right, so that's kind of the high-level architecture that you need to put together to deliver Netlify. Netlify, I'm still unsure. Okay, brilliant. Who's worked with Terraform so far? Okay, yeah, a few people. Who's tried to refactor Terraform? Yeah, exactly. Okay, refactoring Terraform is an absolute nightmare. If you have a really large code base, it gets really difficult because of the way in which Terraform goes, the way in which Terraform's working under the hood is it queries a bunch of cloud APIs provided by GCP or by AWS, takes all those results, writes it to a JSON file stored locally, and then diffs that versus the set of deployed resources that it thinks you should have based on your code base. And then the difference between those two things is the change set that it's going to go and apply. Because it's using JSON to manage kind of all that state under the hood, if you change the path to any of the resources, it goes, oh, you just deleted that resource. It's not smart enough to know, hey, I've moved that elsewhere in my code base. I've refactored that package of resources into a bunch of modules, into a reusable component that I can build upon in future. So that makes refactoring really, really difficult, which means that up front, you need to take some design decisions about how you're actually going to build your Terraform modules. And that's quite interesting to talk about here because there's probably logical groupings of these things. And if you take kind of like a OO design perspective on it, you probably want to like encapsulate the things or the blocks of resources that are going to change each time. So if you kind of look at this architecture, probably your HTTPS forwarding rule and your target proxy and the SSL certs associated with that and your CNAMEs or your A records probably aren't going to change very much. The URL map is probably going to change very frequently. Your backend service is probably also going to change quite frequently. So you kind of got one logical grouping here of these 3 boxes, one resource here that probably doesn't even need a module, and then 2 resources bundled here into a single module as well. And the same is the same with the HTTP forwarding rules. So actually in this case, our backend to this URL map is always going to just be a HTTP redirect service. That's probably not going to change very much. So actually maybe in this case, you can kind of bundle everything together. Right, so what does that kind of module structure look like in code? So if I...
Zoom it up a bit, please.
Yeah, sure. How's that? Yep. It's so large now that I can't even see to use it. I have to take a step back. Cool. So if we just take tree here. So this is like a repo I built for the HTTPS load balance we were looking at earlier. I've kind of split the code base into a few different subdirectories. So at the top level, there's a subdirectory called modules. Modules has all kind of like my reusable components in it. You can see here that these should be recognizable entities from the architecture we were looking at before. So there's a module for my backend service, how I handle my DNS zone and my DNS record configuration. There's one for my front-end load balancer. There's a managed instance group as well. So the managed instance group is how I can auto-scale a bunch of different VMs up and down based on load. And that's what I use for my HTTP redirect service under the hood. There's the module which defines the GCP project itself, and then there's one for the VPC. Actually, VPC is kind of jargon-based. Does everyone know what that is? That's a virtual private cloud, so it's cloud-based networking. So all of your VMs and so on need to be attached to a network. They have to know how to route to each other, and that's what the VPC is. Separately, the modules are kind of like the reusable pieces of Terraform, so I don't have too much configuration stuck in there. I'm using variables so I can template them and reuse them for different purposes. I have a separate subdirectory which handles my projects. So projects tells me how to assemble my modules together. So if I want to put together like a netlify site, I still can't say it. Then how do I do that? How do I compose those modules? And then environments is how I handle the tiering that we were talking about within Bulb before. So for this kind of like toy use case, I've just got one environment defined, which is like a production main.tf file there. Clear so far? Moderately clear? Yeah? Okay, cool. What was I going to talk about next? Architecture solutions, structure of the code. Sorry, I'm nowhere near as slick as Bartos. Structure of the code, Terraform plan on fly. Okay, cool. So, for those who haven't seen it before, this is Terraform. Terraform uses something called HashiCorp language. It's kind of like a markup that declares what your resource should look like. So, rather than like writing a bunch of Python or something like that, instead you have these kind of marker objects. Each one's kind of delimited by curly braces each time. These aren't great examples. Here's a VM definition here, or a template of VM definitions. You can kind of see that this defines your network interface, the subnetwork that I'm attached to, the region I'm deployed in, the machine type, so what actually my VM spec is, what the CPU is like, what the memory is like, how it's named, the disk that's attached to it, what my boot up image is, pieces of information like that. Kind of everything that you'd expect to see. Cool, so we kind of got all of this code which deploys a cloud environment. It's kind of well structured, it's assembled in different ways. Let me just show you that assembly as well, actually. These reusable modules, core main. here's the kind of bits where I'm wiring together all the modules. So you can see kind of like the DNS zone getting declared here. Again, it's still templated with some different variables, my VPC, my backends. And then finally, that core module gets used within env, and then here's my production environments here. So you can see I'm deploying a site called whoosh.com. The admin group is foo@bar.com, and everything else is pretty much templated from there. So I end up with just this one core project definition and my backend definition for Terraform. That's where my state file is going to get stored in the top level module. Cool. So, okay, so how might I go about deploying this type of stuff? Well, I could do it manually. So you can run Terraform from the shell. Basically, the paradigm is that you plan, that gives you an error message. Enet goes and downloads a bunch of plugins so it knows how to parse the different resources and work with the different APIs when it actually goes to do the plan. Well, it's doing the plan, it's doing the piece I was talking about before, where it's going and hitting all the Google APIs in the background, regenerating the state, and then figuring out if it needs to make any changes. I've been working on this like over the last 24 hours or so at the moment, none of my changes actually need to change, like no changes need to be made. If we go instead, adjust this, change something like, what should we change? Thinking of like names under pressure is really difficult. I spend a lot of time interviewing people and they're like, oh, I can't think what to call it. I'm like, oh, it's okay, take your time. Okay, cool. Let's, yeah, I'm in the right directory. So let's plan again. You can see now, hopefully, Terraform's now worked out that because I've changed the name of the GCP project, it needs to tear down absolutely everything within GCP and then redeploy that entire environment. So there was a GCP project, which is like the container for all of my GCP resources, called Special Bassoon. I've now changed it to Special Joy, and so it's going to redeploy everything into that new project at that point in time. So that becomes quite powerful. You can quickly spin up and tear down infrastructure really, really quickly. So if, for example, you wanted to do something like make an application code change and then in your CD pipeline spin up all of your infrastructure, deploy your code, seed it with test data, and then execute a bunch of integration tests in that entirely new environment, that's actually possible. It'd be extremely brittle and I wouldn't recommend it, but it's possible. And that's kind of what you can do with Terraform. Cool. Okay, let's have a look at the Circleci. So where does Circleci fit into this? So how can we actually go about? So the other bit that Netlify were doing was getting fired, like the continuous deployment pipeline was getting fired based on a webhook notification coming from GitHub each time, right? And then they're going and checking out your code and then deploying it. So you can do that with GitHub webhooks yourself, or you can use a third-party SaaS like Circleci. Many people here using like a managed CD. A few people. Okay, cool. Yeah, look at Gerdiel is a sales rep from Circleci. He's come this evening. He's extremely disappointed, or maybe he's really happy because there's loads of people to sell to. I don't know. This is we use like Circleci extensively at Bulb. Pretty much every single repo internally has a CD pipeline defined. All of them get executed by Circleci. All of them deploy into GCP. The construct that Circleci uses is a YAML config file. What really irritates me about this is that the file extension is .yml. Gerdiel, actually, if you check the, I actually loaded this up to show you earlier. If you check the YAML FAQ, it's supposed to be .yaml, not .yml. But we can leave that for a different day. Cool. So this is what kind of Circleci config looks like. So they have a few basic basic constructs. I probably should have put a diagram together for this with hindsight. So they have commands, which are kind of like bash commands that you might fire. Commands are assembled into steps. Steps are assembled into jobs, and jobs are assembled into workflows. So if you kind of imagine how that might work with Terraform, you probably expect to see something like a job which goes and checks out your code and sets up your bash environment. You probably expect to see a job which then goes and runs static analysis over the Terraform code. So potentially runs validate. It's like a command you can run in Terraform to check that all of your configuration is actually correct and you haven't made any syntax errors. Run something like an auto formatter as well to check that your code is neat and other people aren't going to get really upset at you. And then you probably want to plan a little bit like we looked at before, and then apply. And that's kind of what we have going on here. It's YAML, so it's not as clear as it could be. But we have our commands, so Terraform init, which I just ran from the shell before, and then plan. This is a plan step down here, so I'm saying I'm in CD mode, so turn off any input. I've templated the steps so I can adjust the kind of subdirectory where the Terraform plan executes each time. And that's how I can get the tiered environment working that we were looking at before. So it's defaulted at the moment to execute within the prod subdirectory in the repo. But if I change that and added a subdirectory for, say, staging or dev environments, that's kind of how I would do it. And then I'd execute Terraform separately from each one. I then have the apply steps. So yeah, I have the apply steps. So apply takes the plan output generated by the previous step and then goes and applies it. The jobs are defined, they're the commands. The jobs are defined a little bit further down here. So again, here's the validate infra job composed of steps, and then the steps are running validate and then format. Plan and apply jobs, and then here's the workflow definition where the jobs get assembled together into a sequence of tasks or events. So validate, plan, hold prod at that point in time. So we've done our plan, we generated the change set that we want to look at. We hold it for a manual approval. Someone goes in, checks the plan, hits the button, and then we go and apply the infrastructure. And all of that comes together in the Circleci dashboard. And it looks a little bit like this. So I ran this a little earlier this afternoon. Fortunately, it succeeded. Check out on the left-hand side, the validation step we were talking about before. If we click into that, we can see that I've initted, validated, formatted, and so on. For some reason I can't scroll down. Plan. I've persisted my plan to my workspace. After that's executed, maybe we can talk about that in a second. Here's all the failed ones. How I was trying to get it working. The hold step, where you can see that I was the person who went in and approved it, and then the apply at the end. And the apply has just said, hey, I've got nothing to apply, and then these are the outputs that it prints back to screen when it completes, which is just the name server information about, and the IP address that the app is being served on. And that's about it. Cool.